Hi everyone, I'm Cheryl. In this problem, we have a particle that's moving along a straight path, and its velocity function is the function 5t minus 7, and I'm going to be interested in seeing what happens on the time interval from 0 to 3. Now this problem asks for two different things. The first thing it asks for is the displacement of the particle, and then later we'll talk about the total distance traveled. Now one thing that's important to know is that those two items, displacement and total distance, are different things. If you think about it, if we have a particle that's moving along a straight path, it's going to move in one direction and then it can change directions. Now I'm going to go below, but think about it as moving on that same horizontal line. And then maybe it turns around and changes position again and ends here. When I talk about displacement, I'm looking at the difference between the starting and the ending point. So I'm really looking for the distance from here to here. So the difference between the starting and ending points. That's displacement. Total distance, on the other hand, wants to measure the complete length going forward and backward along my path. All right, so how do I find displacement? Well, because I'm looking for a change between the starting and the ending point, I need to talk about the position of the function, and I was given the velocity. Well, we know that if you have position, you take the derivative to get velocity. Well, if you have velocity to get the position, you need to take the integral. So displacement is defined as the integral from a to b of my velocity function. So for this particular problem, my velocity function is 5t minus 7. And I'm interested in what happens from t equals 0 to 3. So now I have a basic integral that I can solve. So I've got 5t squared divided by 2 minus 7t, and I'll evaluate that from 0 to 3. Plugging in my upper limit, I'll have 5 halves times 9, which is going to be 45 halves, and then I'll subtract 21. I then subtract what happens when I plug in the lower limit, which will just be 0 minus 0. So 45 halves minus 21 is 45 halves minus 42 halves, or 3 halves. In this particular problem, my position is measured in feet, so this will be 1.5 feet. The total distance, the displacement traveled. All right, now let's talk about the total distance. Well, how is that different in my formula from the displacement? What I want to do is I want to take the absolute value of my velocity function. So the formula is very similar, but it's the integral from a to b of the absolute value of my velocity function, which in this case is going to be the integral from 0 to 3 of the absolute value of 5t minus 7 dt. Okay, now I don't have a basic rule of integration for evaluating the absolute value of a function, so I need to rewrite this a little bit. And what I know is that if 5t minus 7 is a positive number, I really don't need the absolute value signs because the absolute value of a positive number is positive. It's redundant. However, if 5t minus 7 is negative, I do need those absolute values because I want the positive version of it. So in other words, the question is, when is 5t minus 7 positive and when is it negative? Let's do a little side work to find out. So I'm going to take 5t minus 7 and set it equal to 0. I'm going to solve it for t. So 5t equals 7 and t equals 7/5. That means my function equals 0 at 7/5. And if I look at my interval, and remember I'm interested in what's happening between 0 and 3, 7/5 is right in the middle of that interval. So 7/5 is right about there. Okay. And if I look on the interval from 0 to 7/5, take any number in between there. Let's try a 1. And see what happens to the original 5t minus 7. Well, if I plug 1 into this, I'm going to have 5 minus 7, which is a negative number. If I pick anything bigger than 5, or bigger than 7/5 and smaller than 3, let's try 2. I'll plug 2 into my original function, and I'll have 10 minus 7, which is a positive number. This tells me that any value between 0 and 7/5 is going to be a negative value. Anything between 7/5 and 3 will be a positive value. So on this second interval, the absolute value signs are not needed because the value is positive. But on that first interval, I'm going to have to do something so that I can ensure my function value is positive. Well, what can I do? Well, what I'm going to do is I'm going to split this integral into two pieces, 0 to 7/5 and then 7/5 to 3. So I'm going to have the integral from 0 to 7/5. Now remember, if I just write 5t minus 7, my answer is negative, and I want the answer to be positive. So instead of writing an absolute value, I'm going to negate 5t minus 7. That has the same effect as making the 5t minus 7 positive. I'm then going to add the integral from 7/5 to 3 of 5t minus 7 dt. Remember, on this interval, my function's positive, so I can just get rid of the absolute value signs. All right. Now I'm ready to do the integration. In this first piece, notice I have a constant multiple of -1, so I can pull that out. And the integral of 5t is 5t squared divided by 2. The integral of minus 7 is minus 7t. And I'll evaluate that from 0 to 7/5. Then I'm going to add the next integral. This time I have 5t squared divided by 2 minus 7t. And I'll be evaluating from 7/5 to 3. Okay, now it's time to plug in my upper and lower limits for each of the integrals. So let's try this. We'll have minus 5/2 times 7/5 squared minus 7 times 7/5. I then subtract what happens when I plug in the lower limit. But notice what happens when I plug in the lower limit. I just get 0. So I'll be subtracting a minus 0 minus 0. Now for the second piece, I'll plug in the upper limit of 3. So I'll have 5/2 times 3 squared minus 7 times 3. And then I subtract what happens when I plug in the lower limit. So that will be 5/2 times 7/5 squared minus 7 times 7/5. All right, I have a lot of fractional arithmetic to do, but the answer turns out to be 113 divided by 10. And if you want to get a decimal approximation for that, 11.3 feet. I hope that was helpful. Thanks.